Chapter 15, Problem 8. Consider the following elementary reaction. The rate constant for this reaction is 0.86 per molar per second at 600 Kelvin. Into a rigid evacuated container, 2.5 atmospheres of A is added. Calculate the total pressure in the container at 600 Kelvin after 20 seconds. So I'm going to write down the reaction. We're starting off with 2.5 atmospheres of A, no B, no C. As the reaction goes forward, we would expect A to go down, B to go up, and C to go up incrementally based off of the molar coefficients. So at this particular time, we should have 2.5 minus 2x, and x. So now the question is, how in the world are we going to solve for x? Well, we're given time, and we know that the equation of the line has time in it. But the question is, which equation of the line do we use? Zero order, first order, second order? Well, we're given this little word here that would be an easy oversight. If it's an elementary reaction, that means that the coefficient is the same as the order. So if we look here, the coefficient of A is 2. So that means that it's second order. So if I just said, consider the following reaction, you definitely cannot make that leap by any means. But if they use the word elementary, it's definitely okay. So now, what is for second order the equation of the line? The equation of the line is 1 over A equals KT plus 1 over the initial concentration of A. Now we have to note that K has molarity units. So if I want to plug numbers into this equation, they have to be in molarity. So remember that molarity is moles over liters. We're given pressure. So we know that the ideal gas law has moles and liters in it. So if I take the ideal gas law and manipulate it for P over V, you get pressure over RT. So the molarity of A initial is 2.5 atmospheres over little r and the temperature is 600 Kelvin. So the initial concentration of A ends up being 0.0508. Okay, so I'm going to plug that back into my equation of the line. So 1 over A equals K, which they gave us, 0.86. They gave us the time, 20 seconds. And our initial concentration is 0.0508. So A ends up being 0.0211 molar. Now I'm going to convert that back to pressure. So pressure, taking my equation over here is molarity times RT. So the molarity we got 0.0211, little r, (600 Kelvin). So the pressure of A is 1.33. Okay, so this number right here, 1.33, is the pressure of A. So we could use that to solve for X. We could say 2.5 minus 2X equals 1.33. So X ends up being 0.58. So now if I want the total pressure, that's the pressure of A plus the pressure of B plus the pressure of C. So A, we already know 1.33. B is 2X, so 2 times 0.58. And C is just X, so 0.58. So that gets us a total of 3.08. Closest answer, 3.09.